Myself, Dr. Anil Kumar, HOD, PG Department of Chemistry. Today we will discuss a new topic, Heisenberg uncertainty principle. This is very important topic as it comes generally in the exams. Basically, what is Heisenberg uncertainty principle? That is the position and momentum of anything cannot be measured simultaneously. So, Heisenberg uncertainty principle indicates that as a consequence of dual nature of matter and radiation, Werner Heisenberg is a German scientist or German physicist in 1927 forwarded a principle about the uncertainties in simultaneous measurements of position and momentum. Remember this thing, position and momentum. Therefore, of small particles. According to the uncertainty principle, it is impossible to measure the simultaneously both the position and velocity, you may see it momentum, of a microscopic particle with absolute accuracy or certainty. Mathematically, we may write delta x into delta p is greater than equal to h upon 4 pi. Say it equation number 1, where delta x is equal to uncertainty in the position, delta p is equal to uncertainty in the momentum, and h is equal to Planck's constant. Therefore, here the sign, this one greater than equal to means that the product of delta x and delta p can be either greater than or equal to h upon 4 pi. That is, it can never be less than 4 pi. Since the minimum product of delta x and delta p is constant, therefore delta x is proportional to 1 upon delta p. Say it equation number 2. That is, if uncertainty in position, that is delta x, is less than the uncertainty in the momentum, that is delta p, would be large. One is small, another will be larger. Similarly, if the uncertainty in the momentum, that is delta p, is less than the uncertainty in the position, that is delta x, then would be larger. Therefore, for solving mathematical problem, Heisenberg uncertainty principle equation will be written as delta x into delta p is similar to h upon 4 pi. Say it equation number 3. But delta p is equal to m into delta v. Therefore, delta x, put the value of delta p from this point into this. So, del x is equal to m del v equal to h upon 4 pi. Therefore, delta x into delta v, in this side, delta x into delta v is equal to h upon 4 pi m. Say it equation number 4. Thus, the position and velocity of a particle cannot be measured simultaneously with certainty. This is all about. Pause kar lo. Okay. Uncertainty principle applies to position and momentum along the same axis. Thus, if delta x is along x-axis, then delta p should be along x-axis. It is further important to remember that the uncertainty principle is not an account of any limitation of the measuring instrument. Now, continuation of that, now we will discuss about the explanation of the Heisenberg uncertainty principle. For this, just we have draw a figure here. This is the microscope. This is the microscope, and this purple line is a incident photon. Okay, and suppose this is the electron, and the position of the electron originally is like this. Okay, this is the original path, and new path of velocity may be like this. okay, and the reflected photon will be this. So this is the figure 1, which indicates about the change of momentum and position of an electron on impact with a photon. Now the brief discussion about this figure is this. Let us consider both position and momentum of an electron. For the experiment, the pin point is the position of electron, so we use light. So we use light, so that the photon of light strikes the electron and the reflected photon is seen in the microscope as shown in the figure 1. As a result of hitting, the position as well as the velocity of the electron is disturbed, but according to the principle of optics, the accuracy with which the position of a particle can be measured depends upon the wavelength. Remember this thing, wavelength of the light used, that is the uncertainty in position. चलो शुरू करें. That is the uncertainty in position is plus minus lambda. That is, the smaller the wavelength, the greater is the accuracy, but shorter wavelength means higher frequency. Remember this thing, shorter wavelength means higher frequency and hence higher energy. The high energy photon on striking the electron changes its speeds as well as its direction. Now this is the explanation of the figure. Now what is the significance? What is the significance of Heisenberg uncertainty principle? Therefore, like de Broglie equation, although Heisenberg uncertainty principle holds good for all objects, but it is of significance only for microscopic particle. Remember, microscopic particle. The energy of photon is insufficient to change the position and velocity of a bigger bodies when it collides. Thus, for a particle of mass 1 mg, delta x into delta v is equal to h upon 4 pi is equal to 6.626 into 10 to the minus 34 kg meter square per second divided upon 4 into 3.14 into 10 to the minus 6 kg. On calculation, we got 10 to the power minus 28 meter square per second. Thus, the product of delta x and delta v is extremely small. Thus, for a microscopic particle like an electron, we have delta x into delta v is equal to h upon 4 pi. Put the value of Planck's constant 6.626 into 10 to the minus 34 divided upon 4 into 3.14 into the value of that one 9.11 into 10 to the minus 34 kg. On calculation, we got 10 to the power minus 4 meter square per second. Generally, with this one problem comes for regarding uncertainty principle. Number one problem is before you is this: the uncertainty in the momentum of a particle is 6 into 10 to the power minus 2 kg meter per second. Calculate the uncertainty in the principle or position. So solution, uncertainty in the momentum is given, that is delta p ka value is given 6 into 10 to the minus 2 kg meter per second square. So according to Heisenberg uncertainty principle, we know that delta x into delta p is equal to h upon 4 pi. Therefore, we have to calculate the delta x. So delta x is equal to h upon delta p into 4 pi. Put the value of Planck's constant, put the value of p and put the value of pi. On calculation, we got 8.76 into 10 to the minus 34 meter. This is all about this class. In next class, more numerical is there. More numerical based upon Heisenberg uncertainty principle. उसको घूम के ले लो. अब शालिनी का कौन लेगा? हम लेते हैं. सो थैंक यू, आप कर लीजिए।